Good day to all. Welcome back to the Liceo Math Club tutorials. This is your Executive Vice President, Boy Dejella. Today our topic is all about the applications of the standard normal curve. Before we proceed, let us first review the previous lessons related to this topic. First, solving for the z-score. And second, finding areas under the normal curve, which includes the areas to the left, areas to the right, and areas at the center. Solving for the z-score. As we all know, the standard equation is z is equal to x minus the mean or mu all over the standard deviation or sigma. Also, we might have this inverse equation handy, which is x is equal to z times sd plus the mean. Next, in finding areas under the normal curve, we will use the z-table, which provides certain areas to a corresponding z-value. Also, we should keep in mind that in solving areas to the left or the probability of z less than the z-score of x, we just copy its corresponding value from the z-table. While in solving areas to the right or the probability of z greater than the z-score of x, it is equal to 1 minus the probability of z less than the z-score of x. It is because the z-table only provides areas to the left. So, knowing that the normal curve has a total area of 1, we can find areas to the right by subtracting areas to the left from it. Lastly, in finding areas in between of two values of z or the probability of z greater than z sub 1 and less than z sub 2, we just subtract their areas to the left. Probability of z less than z sub 2 minus probability of z less than z sub 1. Okay. So we are now ready for the main topic, the application of the standard normal curve. Suppose that a coffee vending machine fills a mean volume of 120 milliliters. This volume deviates by 5 milliliters and follows a normal distribution. Like any other machines, vending machines aren't always exact like as it says on their posters. Sometimes instead of a 120 milliliters it gives 118 milliliters or 129 milliliters and so on. So, going back to our problem. A. Find the probability of getting less than 110 milliliters of coffee. B. What about at least 132 milliliters of coffee? And C. What is the probability of getting a coffee with a volume in between 115 milliliters to 130 milliliters? First thing to do is to identify the given and asked. As stated in the problem, the mean is equal to 120 and the standard deviation is 5. The given in situation A is x is equal to 110 milliliters. We should find the z and its probability. In situation B, the given is x is equal to 132 milliliters, then we should find z and its probability. Because the restriction there is at least, the probability we should get is the area to the right. Next, in situation C, the given values for x is 115 and 130. So, we need to find the z sub 1 and z sub 2 and the area in between them. Let us solve for the first situation. Given the mean, SD, and x, we can now find the value of z. Using the standard equation, we will now substitute the values. Evaluating the operations, we get -2 is the final z-score. Then, using the z-score, we can now get its probability. The probability of z less than the z-score of x, by substitution, is the probability of z less than -2. Because it is less than or to the left, we can directly get its area from the z-table. Which is 0.02275. Multiply it by 100 to get its percentage, we get 2.28%. So, the probability of a person to get a coffee with less than 110 milliliters is 2.28%, which is very rare. To put it into a graph, this is what it looks like. This area only covers 2.28% of the normal curve. Next, The second situation given is the mean, SD, and X as well. We can now find the value of Z with this. Using the standard equation again and substituting the values, we get Z is equal to 2.4. With this, we can find its probability. The probability of Z greater than the Z-score of X is equal to 1 minus the probability of Z less than the Z-score of X. We will just substitute 2.4 to the Z-score there and find on the Z table its corresponding area. Its less than probability is equal to 0.99180, so we subtract it from 1 to get its greater than probability. Multiply it then by 100 to get 0.82%. As answer, the probability of a person to get a coffee with at least 132 milliliters is only 0.82%, which is super rare. This is its normal curve look like, with area only covering 0.82% to the right. Last situation, C, the given are the same values with two x's of different values. We can also find two values of Z here. Using the same procedures from the previous problems. We get Z sub 1 is -1. And Z sub 2 is 2. With this, to find the probability of the area in between them, we can use the equation. The probability of Z less than Z sub 2 minus the probability of Z less than Z sub 1. First, find the area of Z sub 2 on the Z table, which is 0.97725. Then the area of Z sub 1, which is 0.15866. Subtracting the areas, we get 0.81858, which in percentages, 81.86%. In conclusion, the probability of a person to get a coffee with between 115 to 130 milliliters volume is 81.86%. This is the area in between the plotted points, -1 and 2. The area 81.86% greatly covers the normal curve. Let us now move on with problem number 2. The average weight of a Filipino is 55 kilograms with a standard deviation of 8.3 kilograms. Situation A. Mina's weight is 50 kilograms. In what percentile does she belong? And situation B. Andy belongs to the lower 42% of the population. What is his weight? Take the first step again. Identify the given and the asked. In the general problem, it is given that the mean is 55 and the standard deviation is 8.3. In situation A, the value of X is 50 kilograms and we needed to find its percentile or probability, along with its Z-score. Oppositely in situation B, the given is already the probability and we need to find its Z value in weight, or X. Situation A. Given the mean, SD, and X, we can find its Z-score through substituting the values to the standard equation. Evaluating, we get -0.6 as the Z value. With this, we can simply solve for the probability by finding its corresponding value from the Z table. We then get 0.27425, which is, when converted to percentages, 27.43%. Therefore, Mina's weight approximately belongs to the 27th percentile. This is the area coverage shown in the normal curve. Situation B. Given the mean, SD, and probability is quite a bit tricky. But the process is just the opposite. First step, we know that 42% converted to decimal is 0.42000. We just need to find this area in the z-table to find the z-value. As shown, there are two values, -0.20 and -0.21, that are close to the given area. We just need to get its average for us to have the z-value, which is -0.205. Then with this z-value we can now have the x. How? By using the inverse equation I previously mentioned. X is equal to z times SD plus mean. Then, substitute the values and evaluate the operations. We then get x is equal to 53.5. In conclusion, Andy's weight is approximately 53.5 kilograms. This is the graph of the given situation where the -0.205 covers 42% of the curve. That would be all for today. I hope you have learned a lot. To watch more video tutorials, please like and follow our official Facebook page at Liceo Math Club, and subscribe to our YouTube channel, Liceo Math Club. Thank you for watching.